Hey guys, welcome to a new tutorial. In the next few episodes, we're going to be writing and reading shaders so we can give our game a little bit more. So some kind of post effect, some kind of, say, outline, you bend the world, all that kind of stuff can be done with shaders. And we are going to start right away today by not writing anything actually. Today we're going to be looking at a standard shader. So when you create one, they have some values in there by default. We're going to go ahead, read it, and try to understand it as best as we can. And this episode is actually really crucial because you need to understand what we're doing if you want to follow along with the next examples. So I'm just going to put that on pause really quickly. I am in my scene right here. I basically just have this mesh right here, which is my debug platform. Not really going to be any useful today. And also the water. Let's just give it some cool look. I don't know. Well, let's go ahead and right click in our project folder, create. And the shader we're going to be starting to write today is a Unlit Shader. Throughout the next few episodes, we're going to be covering the surface shader, the Unlit Shader, and also the image effect, which is, in my opinion, pretty much the same thing as the Unlit Shader. So today, let's have a look at the Unlit Shader. I'm going to create it real quick, and I'm just going to call it test for now. And let's open it up. And we're going to have a look at it right now in the game by changing the first line actually. So if you scroll at the very top right here, the first line is actually telling you this is where it's going to put your shader in. So if you have a quick look, say in Unity, I'm going to create a new material for this. So create material. I'm also going to call it test. Doesn't matter if it has the same name. There's no naming convention here. So let's have a look down here. We have the standard shader at the very top right. If we click on it, we should see our shader under Unlit and Test. Here it is. So you pretty much understood that this actually defines a directory and then the file name. So if we go ahead and just go ahead and create our own directory, so we'll say n3k and this is going to be test, you're going to realize that our shader has changed folder. Right now he's under n3k and then test. And we also have a preview. If we just pull this right here, you can also have a preview of your shader. Right now it is a standard unlit. I think it actually supports a texture. Yep, it does. And it's not applied to any object in the scene. So we might actually want to put it on a object. So I go ahead, create a new game object, cube, and I'll just move it up, say right here. Now when I click on it, you can tell that by default, it has default material in Unity. Now we don't want this. We want to have our own material that uses our own shader. So we're going to drag and drop test on top of it, right here. Now this object right here is actually being rendered using the instruction in this file. If we go ahead and we just turn off the lighting, you're going to tell that this one is not being affected because by default, the actual shader we created, well, these default value, they don't use lighting. And that is why it was a unlit shader at first. So this is simply to prove that they have different instructions. Now let's go back in the actual shader. Let's have a look at the properties tab at the top. So properties are pretty much the input you have on the actual shader itself. These are going to be defined in the material. Let's give it a look right here. There's multiple type of properties we can send to our shader, such as you can tell right here, this is a texture. We can have another one, so you could say secondary texture. There again, there's no naming convention, but usually when you have a main texture, Unity likes to call it main text like this. And then you could say this is a second texture. You're also going to realize that when you write shaders, you don't have IntelliSense, so make sure you don't have any mistakes in everything you write, basically. Also right here is a default value. I think I could put that on black and have a default value of black right here if we go back on the material. And here it is. So default value on black didn't work. But as you can tell, we've got our second texture right here. Now we could go on it and actually put anything really, but you're going to realize that it doesn't do anything to the cube. It doesn't do anything because we never actually ask our shader to do something with it. So it's pointless for us to have a second texture right now. But this is just to show you that you can actually send input to your shader using properties. Now there is other kind of properties you can use, such as we're going to go with colors. So color tint, maybe. You see that quite often. You always give it a name first, so that's the name. Well, no, actually the name is right here, and here is like a definition for the inspector. So you saw, like, this is the second texture, you saw it right here. And then afterward, you declare the type of this. So in this case, this is going to be a color. And you have default parameters you can put. So I think color is like this, I'm not sure. Hopefully it is. And yeah, here it is. So tint is white, so 1111. Now if we go here and say 0.5, it should also change in the tint, if we hit the reset, of course. And here we go. So 10511 is actually a nice looking pink. Let's put back a texture on this. And as you can tell, even though we have different tint, again, we're never actually using the tint in our shader, so it doesn't care. We're just adding, you could call them fields, we're just adding variables to this. There's other kind that you can also use, such as a vector3 position. Just say, one I like to use is character position. Of course, the naming doesn't really matter, you can name it whatever you want. But you can also send in a vector. Now by default, this is a vector4. And I believe we got it right here. So characters position, X, Y, Z, and W. Again, this is something I could be changing from another script or manually right in here. And even though I change it here, no visual has been affected on this because, of course, we are not using it in the shader. So I think you get the idea of this. There's also other type that I won't go into like much detail here. There is the float, and there is also the cube map, or it's actually only called cube in caps. So those are some of the types you can actually be using to control your effect from outside. Right now, the only one we need for a standard unlit is a main texture. This is where things get a little bit more complicated. This is where we actually start creating passes, and we're going to talk a lot about passes in the future, but right now we only have a single pass in this shader and we have to cover all of it. But right before we jump into the actual pass, I'd like to have a look at these two instructions at the top right here. So tags is basically just a dictionary that you can set some values. So these one are something you have to Google. You can't really know like what kind of parameters you can change without really Googling. Render type is actually telling you in which order this shader is going to be rendered, basically. So if you have something that has some transparency to it, you have to put it at the end of the render queue, so it's going to render once everything else is done, basically. You can have a look at the list right here. So opaque is the one we're using. I think that's also the first one. Then transparent cutout. Okay, no, it's not actually in order. But you would actually pick the one that actually fits what you need. So overlay, I guess, would be the last one. Opaque has to be in the beginning. I'm really not quite sure, to be honest. But usually when I have something transparent, I just put it on transparent, and when I have something that is opaque, put it on opaque. If I do UI, I put it on overlay. This one could also be cool, but I've never really did skybox shader. Anyway, so this is what the tags are for. There's other tags as well, such as preview type. I think you can actually change the preview type from a sphere to a cube, which could be fun. Next one is LOD. So after 100, I think that's meters, it should actually not render your pass, but I've never had that problem before, or I've never really dealt with that before, because it's always being rendered even though I go super far. So I'm not quite sure what LOD, well, I mean, I know what LOD is for, it's just I really can't get it to work on my shader, so that I'm actually going to abstain saying anything else about it right now. But LOD stands for level of detail, and then you put your number. By default, everything's always on 100. I think the biggest one goes to 250. And now we finally get into the pass. So the pass is really interesting, actually. Whenever you're in the pass, you always have to be putting everything you do right here. It's always in CG program language, so you have to put it in between the CG program and the end CG. That is really important for everything else to work. And this is also going to cause us a mess when we try to debug, because that CG language is not really easy to debug, especially in Unity. So let's have a look right here at what we have, because this is where it gets super fun and also super complicated. The first thing I'll do is I'll get rid of this, because this is not there by default, and it's actually going to put us like it's actually going to make things a lot more complex to understand at first. So I'm going to remove the fix to get the fog working, and then afterward we're going to be looking at these two right here, Pragma Vertex Vert and also Pragma Fragment Frag. So what these are, you could say that these are some kind of functions basically. And if we just have a look down here, you're going to see them right here. There is a vert and there is also a frag. So these names are connected. If you were to change this for Vertex Shader, you also have to change it down there. Same thing goes for frag. Now, the name in front of it cannot change. So if you do a Pragma Vertex, it has to say Vertex, and this one has to say Fragment. Those are like defined keywords. Okay, so this function right here is going to be the one taking care of all the vertex. Now, this function right here, frag, is the one that is actually going to take care of all the fragment. And if we do like a quick difference on these two, like what are the vertex and what are the fragments? So what are these for basically? To explain quickly, vertex is for all the vertex on your objects. But exactly what does that mean? That means that currently what we have on the screen is a cube basically. And that cube has a total of 1, 2, 3, 4, 5, 6, 7, and 8 vertex. Now by vertex I mean these things right here. So I'm not sure how to say that in English. I guess I'll just call it vertex. So the one on the edges here, they're not the edges, they're the one that actually finishes the edges. So these 8 points that makes up our cube are actually going to go through this function one by one. And this is really what is interesting to know. It's to know that this is going to be called 8 times every single frame for a cube. Let's also specify that this is for a cube, because if you're going through, say, a character that has 7,000 vertex, which is really possible nowadays, then this function is actually being called 7,000 times. Did I say 700? 7,000. Let's say 7,000, right? Well, this function is going to be called 7,000 times every single frame. And how is that even possible? It's possible because this is running on the GPU and not our CPU. So it's running on the graphic card, it's not running on our processing unit. So graphic card is optimized for that kind of operation. It's made for this kind of operation. So it's really fast and it's not really that expensive. Now if we have a look down here, what are fragments? People actually don't call it fragment so much. They like to call it pixel shader. So we might as well just call it pixel, but let's leave it on frag because that's the keyword they use. And you know, you cannot change fragment from here. You cannot say pixel. That's not gonna work. So as far as the fragment goes, it is for every single pixel in your screen that is going to be rendered. So let's say that we're actually putting our camera right here, right there. So our cube is actually taking our whole screen, as you can tell. Not anymore, now it is. So, well, technically it's almost. Okay, right here. So we have our whole screen covered by the cube right now. Let's just assume that our screen is 1920 by 1080, which is a normal resolution. Then this pixel shader, this fragment, is going to be called that amount. So we're looking at this number, 2 million times every frame, because it has to actually lit every single pixel one by one. So it doesn't matter if it's our cube, it doesn't matter if it's our whole screen. In the end, this pixel shader is going to be called 2 million times on pretty much every frame. So again, this sounds really expensive, but it's not, since we're on the GPU and it's actually optimized for that. Now, what kind of operation can we do on this? Like, what can we actually do with these, and what can we actually do with that? If we have a quick look, and I know I've skipped this part right here, but if we have a quick look at what this does on the vertex, So we saw the vertex shader, which is to position the vertex in the 3D world at the right place, and we saw the pixel shader, which is to light the pixel and actually give it the proper color. Now, I didn't really give any example with this one. The vertex shader could be used for deforming the mesh. So if you have a look, say, at this ocean in the background, this ocean is actually just a plane. It's a regular plane. It is super flat, but as you can tell, it actually goes up and down, and this is done with the GPU. As you can tell, even if I click on it, I can't click on it because this is actually not where it's positioned in the data of Unity. It's not supposed to be here, basically. But what the GPU does is actually it takes that vertex, it does some calculation, and then it bumps it up in the world. This is done via the GPU, and Unity doesn't know about this, basically. There is some shaders online that actually add snow on top of elements. So say this object right here, we could put snow on top, so it would actually bump every single little edge here. It would bump it up and add the white color to it. There is a bunch of things you can do with the vertex shader, basically. So like I said earlier, let's actually assume that this is a function. Now this function has a parameter right here. This parameter is called appData, and this other function, the pixel shader, has another parameter called v2f. Now these are actually defined right here. So you could say that these structures are actually the input for the vertex shader and the input for the fragment shader or pixel shader. Now if we have a look at the app data at the top, we have a float 4, which is the equivalent of a vector 4 basically. So we have the x, y, z, and w. Now the w we don't use so much for a position, but this is actually going to store the position of the vertex in the 3D world. Now we also have the UV because every single vertex has some UV information to actually map some texture to it. This is done in your 3D software, whatever it is. This is actually where you define the UV for that vertex. So if you do any UV unwrapping, you know what this is about. Now if we have a look down here at V2F, which basically stands for vert to fragment, because once you're actually done running this part, it actually returns the vert to fragment and it sends it over to this guy. So the data that is actually sent to our pixel shader comes from our vertex. So if you haven't figured out already, this is always ran first, and then once this is done running, it actually takes the return, so this return right here, which is a V2F, and it sends it over to the pixel shader for a lighting purpose. And inside of it, you can have as many fields as you want, and that's also true for the app data right here. You can have as many fields as you want. You can create another float, call it intensity, and you don't need to put any param right here. I'll talk more about these in a second, but you can put anything you want in here and then say v2f, or actually o.intensity is equal 5. You can set it right here, and then once it's actually done calculating everything it has to calculate, this is sent over to the pixel shader, and you can reuse that data using the parameter right here. In this case, i.intensity. So this would be equal to 5. Alright, so let's assume that these right here, this is the input for the vertex shader, and this is the input for the pixel shader. Now, we know what actually is inside of here because we define it as much as we want in the vertex shader. So we say o.uv is equal to this. We know what's inside of this. We do o.vertex is equal to this. So we know what's going to be inside of vertex when we send it over to that guy. However, in the vertex shader, we don't really know what is inside of vertex. And this is where the semantic, the actual double dot right here, and then position comes in. Because these are actually defined for us. So when we say 2.position, we know this is actually going to store the position of that very vertex in the 3D world. Now here is a list of semantic I've pulled from Wiki. If we just have a look real quick, we have the vertex position. So this one we're already using. It's a float 4, so like a vector 4 again. We have the normal. This is really useful if you want to know in which direction your actual vertex is pointing. So let's add this to ours. Float 3 normal. You can give it any name you want, such as normal Dave, doesn't really matter. What really matters is what is on the other side of the two dots, so in this case the semantic. Now having this done, we know that normal is going to be equal to the normal, the vertex. I'm currently on the wiki.unity3d, by the way, if you just want to have this list. Now, there is also the UV texture coordinate. This is defined in your 3D software. It also supports another set of coordinates, so you can be putting text coord 1, which is your second set of coordinate. This is also something you support via the 3ds software. Well, not 3ds software, 3D software. I'm using 3ds Max, and I can actually do that. You can have the tangent and also the color. Something people don't really realize when they start making games is, well, actually 3D model, is that your 3D model, they have vertex color, and this is so very useful for so many reasons. Now this one, we're going to be using it quite a lot later on to create some nice blending effects. So say you want to create some kind of custom terrain editor and you want to be blending up to 3, 4, 5 different texture together, you would be able to do that using the vertex color. Unfortunately, there is no real way right now for me to show you what's on top of this because I don't have any 3D model with vertex color on it, but we're gonna have some eventually in the next few episodes, guys. Let's keep actually looking at this real quickly. We covered pretty much everything but this line right here, the using unitycg.cg and also these two right there. So if we just wrap this up, include unitycg.cg is actually going to give us some nice method that is going to pre-compute some stuff, actually give us some like easy way to transfer our 3D coordinate to say screen coordinates and other stuff that Unity gives us to make our life easier basically. So basically this doesn't really have to be here, but we're going to be using it a lot in the future. Now right here, these are something we want to be keeping. This is actually a reflection of your properties. Now about these two lines right here, this one I got rid of it earlier. I don't actually need it, so that's my bad. But what usually happens when you're done declaring your structure of Thea is that you need to replicate what's inside of your properties. Whatever you're going to be using in your past, like right here, you have to replicate it down here. You have to declare it inside of your past as well. Now this 2D texture is actually a sampler 2D. If we had a color such as say tint, like we had earlier, let's put that on say 1111. The reason there is 4 is because we also covered the alpha right here. Then if we want to be using this tint later on, we have to declare it down there by saying color tint. Now I believe that this takes a capital, does it? Oh my bad, this is actually called a float 4, so this is a vector 4. You might have a lot of problem when you make this shader work. You're gonna have to do a lot of googling because you don't really have any way to debug, and you know that's gonna be annoying. But in the end, we should get something a little bit better. So invalid subscript intensity. I've just deleted intensity. Let's get rid of it. Now do we have something that compiles? And I'm still compiling right now. We still don't have anything that compiles. So it says we don't have main text st. So st, what does st stand for? So we had something right here, a float 4 main text underscore st. I'm just trying to remember what the st stands for because you can actually add stuff next to a texture. So you have like underscore st, which stands for something that I'm going to Google right now. A lot of magic happens in the shader. You just have to Google it all the time. So real quick, if we have a look, so according to a Unity graphic engineer, the st suffix is actually some more information about texture that contains the texture scale and also the translation in offset. So now that we have this, we can actually have a look at our shader. And that's actually it. So I know this is a little bit complicated to understand. I know that there is a lot of things that are kind of magic, such as this texture we learned about, but eventually it's gonna get a little bit better as we do more and more, and you're gonna see that we always do the same stuff basically. And feel free to look at other people's shader, feel free to actually start trying to understand them, and once you do, you're gonna be able to make your own basically. In the next few episodes, we're gonna go ahead and start making our own. Right now we're just looking at the syntax real quick, and that is pretty much it. Hope you guys enjoy, hope you understood something, and if you didn't, stick around for a few episodes, get some practice in as we do it. I'll try to explain the actual logic behind the mathematics we're going to be using. We're going to be trying to wrap the world around some kind of toilet paper so we can have this subway surfer feel where the planet always rotates. We can also do other things such as adding glow, adding outline, deforming our mesh, adding some kind of shockwave, bunch of things. Stay tuned, guys. Thank you so much for watching, and I will see you in the next one.